Good morning everyone, I am Shivam from grade 9B and I am a student of GD Goenka Public School. Today I am going to tell you something from my grade 9, and that is energy, and this is a very important chapter. So let's start. So before going on that, we should know that what is energy. So energy means a piece of work done by a human, because for example, if someone is cutting wood, so he is taking the axe on the shoulder and then cutting on the trees. So we tell that person is very energetic. So similarly, that is known as energy. So now let's know few points of energy. So SI unit of energy is also joule. And this joule, the name of joule came from a scientist whose name is James Prescott Joule. So SI unit of energy is joule. So now we should also know the CGS unit of energy. So CGS unit of energy is erg. So we know that both the units of energy, so we should know the relation between them. So 1 joule, one erg is equal to 10 to the power 7 joule. Now let's move to the next second point, that is the types of energy. So generally there are many types of energy, but in grade 9 we have to study just 3. So today I'm going to discuss about the kinetic energy. So mainly there are 3 types of energy. Kinetic energy, which is normally written by Ke, and the second one is potential energy, which is denoted by Pe. And if we sum these two energy, then we will get mechanical energy. So so now let's know something about kinetic energy. So kinetic energy. What is kinetic energy? So kinetic energy is caused by the movement of particles. So let's know about the kinetic energy. So the SI unit of kinetic energy is joule. Similarly, because it's a energy, and we should also always know that all the energies will be always equal to the work done. So we should also know the formula of kinetic energy. So formula is equal to half into mass into velocity square. So now I'm going to derive the formula of this. So before going on the derivation, we have to suppose. So let us take this medium M, and let's suppose a ball of mass. Let us suppose this medium as M, and the mass of this ball be M, and it starts moving with the initial velocity. Here we have to take initial velocity as v, and when it starts moving from point A, and when it enters into a medium M, then the force is applied opposed on this, due to which the retardation happens, and it covers the distance s and comes over here at the final place, and the final velocity becomes 0. So now let's move to the derivation, that how we will find that half mv square is the formula of kinetic energy. So to prove So let's start. So we know that work done is equal to kinetic energy because we have studied right now. And so what is work done? So work done is equal to force into displacement. So similarly, if work is equal to force into displacement, then kinetic energy will also equal to force into displacement. Now, from the third equation of motion, we know that from the third equation of motion, we know that v square is equal to u square plus 2as. But here we are taking initial velocity as v, so we will write v square is equal to is equal to v square plus 2as. And then we know that the ball, we know this here the ball came and stopped over here, so the final velocity is equal to 0. So here we will write 0 square is equal to v square plus 2as. Now let's move ahead. So at last we came as 0 is equal to v square plus 2as, and we got to know that the acceleration is not there, retardation is there, so it will be not positive, it will be negative. So 0 is equal to v square plus minus 2as. So it will be v square minus 2as. So when this will come this side, so it will be equal to v square. So we can write v square is equal to 2as. And let's make it as a first equation. Now, from the second equation of motion, we know that force is equal to mass into acceleration. So we will put the value of A from here into this equation. So it will be force is equal to mass. So what will be the value of S? This will come over here. So it will be V square. It will be not plus, it will be multiply, because we have to put the value. So what will be the value of A over here? Let's see. It is V square is equal to 2as. So the value of A will be from here, that V square by 2s is equal to A, because it is in multiplication, so it will come in division. So it will be 2s. And we know that, now let's move ahead of this. We know that Fs is equal to kinetic energy, is equal to work done. So now it is in division, so we will take it over here. So it will be 2Fs is equal to mv square. So now let's move ahead of this. So Fs, so 2 is again in the multiplication, so we will bring over here Fs is equal to mv square by 2. And what is Fs? Fs is work done, and work done is equal to kinetic energy. So we will write kinetic energy is equal to mv square by 2, and this can be also written as half mv square. So here we have derived the formula of kinetic energy. So now let's move to some numericals. So one question, that a man of mass 5 kg moves with velocity of 10 meter per second. So what will be the kinetic energy? So it's a very simple question. So now let's move to the solution. So the solution starts like this. First of all, before solving any question, we have to write the given data. So here the mass is equal to 5 kg and the velocity is equal to 10 meter per second. So now we will so we know the formula of kinetic energy is equal to half mv square. So it will be half into what is the mass, 5 kg, into velocity is equal to 10. So the square of 10 is 100. So now we will cut like this. So it will be 50. So the answer will be 2500. So this is the kinetic energy opposed by the man. So now let's move to the other type of kinetic energy, that is potential energy. So it is first of all it is by PE and its SI unit is again the formula of potential energy is mass into gravitation force, acceleration due to gravity into height. So again we should know that from where this formula came, how to derive this formula. So it is also very simple. Let's move to the derivation portion. So let's start. So again we will take a ball, is a ground, it is a mass of m, and we will and it covers the height of distance h, and it falls down and comes over. So through this we will derive the formula of potential energy. So we know that work done, because again we have to find the energy, so energy is equal to work done. So work done is equal to Fs. So here the ball is coming down, so acceleration due to gravity should be there. So we know that F we can write as mg, and here S, what distance it is covering? It is covering h distance, so we will write h. So again here work done is always equal to energy, so here the energy is potential energy, so we will write potential energy is equal to mass into acceleration due to gravity, height. So this is derived. So now we will move to our last portion, that is we will solve a numerical related to this. Yeah, and so the question is, a ball mass 2 kg dropped from a height of 10 meter, find potential energy, and it is given that g we have to take 10 meter per second. So now let's move. So we will write that again, we will write the given data. So mass is 2 kg. It is dropped from a height of 10 meter. So height is equal to 10 meter. And here we will take the g value as 10 meter per second. So we know the formula will be m into g into h. So it is, we will write the data as 2 into 10 into 10. So it will be 200 joule. So it will be it is the answer. So that's all for today. Thank you so much for watching.